Microsoft Build 2023, last day 2, kind of. Here to really go through deep Q&A. What we're going to do is just, in case you missed some of the other sessions, we had some of this, the super high level part was covered in Panos's keynote this morning. Then we had a breakout right after at 11 where we went over, I think, 6 different demos that highlighted this. The goal here is I'm going to do about 4 slides just to give an overview for folks that missed that part. And then Vicente is going to go through and walk through the code for about 10 minutes to show you the end-to-end example using Olive with the Whisper model, creating the package, integrating it to an app, showing the app, and then we'll have 30 minutes plus of Q&A. So we'll have online, we'll have in the room. I will try to remember to repeat questions. If I forget, feel free to yell at me or poke me so everyone online can hear. And then I'll be moderating after that from here as well. We have experts on the line. We have experts in the room who will help answer any and all questions that we can. If you can stump us, then we'll have to figure it out. We'll get back to you later, figure out a way to communicate that through. But so the goal is we're going to look at what ONNX Runtime is. ONNX Runtime today was announced as the gateway to Windows AI. What does that mean? That means, thank you. That really means that we're now making public to third-party developers the same internal tooling we're using internally throughout all of our apps and services and so forth. And so we announced last year at Build this thing called the hybrid loop development pattern and the Azure EP to provide hybrid AI inferencing. That's all now real. Everything we're going to show you, there's code repos of this today you can go play with. Every demo we showed is real. Some of it's actually on hardware that's not going to hit the market until later this year or even past then. But you can still utilize all the code and all the repos that were made public. I may have forgotten to put a QR code in here, but for posterity's sake, at ONNX Runtime.ai/build 2023. There's links to 4 blogs and I think 4 repos. There's also some other repos available at github.com/ONNX Runtime. And so they will be continuing to add more and more to there, but you can, again, access all of it. ONNX Runtime is open source. So it's all kept up to date, has contributors from a bunch of the different Silicon partners, as well as Microsoft. Olive as well as open source as well, and is an extensible framework. And so I'll kind of go through what that means. So Olive, think of it, I take a model, whether it's PyTorch, ONNX, etc. I create a configuration file to tell it, hey, here's what I care about for production, as well as what execution provider. And an execution provider is, if you're not familiar with ONNX, is really a hardware accelerator for a specific piece of silicon, or if in the case of DirectML execution provider, it'll abstract away for Windows devices. So I can take it, pass the model. Olive will create a package which has ONNX Runtime, the right execution provider, the optimized models that you sent it. It will have sample boilerplate code in C#, C++, and Python that you can then take and modify mildly to put into your app that will then call the right execution provider based on what you provided it. And then the configuration file for ONNX Runtime itself. And ONNX Runtime is an inferencing engine. The goal of it, part of this is we want to make it easy for developers to deploy AI in Windows, but also realize there's other platforms, and ONNX Runtime works the same across Windows, Windows on ARM, iOS, Android, and Linux. And it's very easy to port things across, and that's the goal. Same thing with Olive. Allows contributions, but allows you to optimize your models for specific hardware and specific platforms. How do we make this as simple as possible? So what you see today, and again, it's going to continue to get added to and expanded. So I kind of mentioned the cross silicon, CPU, GPU. We have the net new or new and newish. Some of it is still coming on the NPUs or neural processing units. You'll hear different names. I think Intel calls theirs a VPU. I think AMD calls it an IPU sometimes an NPU. But think of them all as neural processing units or super efficient AI workload processing processors that were actually made for it, where we've been misusing GPUs that were made for graphics processing. So these are, NPUs are super low power and barely burn any juice, which is amazing for battery life, both handset and PCs and so forth. And they allow CPU offloading. So you can let the CPU be doing other work while I go inference quickly over here, and you'll see some of the speed ups. We also have ORT Web, which allows you to do inferencing in browser. We have Web GPU in preview mode, and coming soon, WebNN will also be coming once we get everything checked in with Intel and ourselves and into the WebNN repos. So QNN from Qualcomm exists today in public preview mode. OpenVINO for Meteor Lake and beyond exists today. Vitis AI for the Ryzen AI platform from AMD exists today. You can go use that. And then Azure EP, the hybrid nature, which allows us a single point of entry for whether I want to call the cloud or whether I want to inference locally. And it puts the control into the developer's hand to say, hey, based on current conditions, hey, do I have low battery life? Maybe I kick it to the cloud. If I have a gateway or a gating model that tells me, hey, based on this input, I won't get that good of a result maybe from the local model because it's a lot smaller, kick it to the cloud. Or I've lost connectivity, then I'm going to inference locally and not go to the cloud. So you choose what the experience you want to drive is. Or there's privacy security concerns, and I really want to keep this local and not transit anywhere off the machine, I can make that call too. Again, it's the same API, you just pass it a different, I want to call 0 versus 1 versus 2 to tell it which EP, whether I want to go to the cloud or I want to stay local. And again, made to be drop dead easy and portable across all of the different platforms. So all of toolchains, the other net new, was just released, especially for the client side. And again, works across all these new execution providers for the NPUs, works for DirectML EP, and again, take an ONNX or a PyTorch or other model, package it with a configuration file, send it to Olive, and it spits out this package with all of this that allows you to go put it into your app. So I can have my model, I have my inferencing, I have my configuration file for ONNX Runtime itself. You plug it in and you go. So why, here's sort of our value props. One, ONNX Runtime, again, cross-plat, portable, and you don't lose performance, I will say, with the portability. We really have tuned this heavily, and it's one of the reasons why we have different execution providers, whether you use the specific ones for specific hardware, whether I use CUDA for GPU, whether I use QNN for Qualcomm's NPU, whether I use DML, which covers all Windows platforms, currently all GPUs. So you optimize with all of once, and for any Windows environment, it just works across all CPU, GPU, and coming in near future, our NPU coverage too. And then when I want to take things and go to iOS or Android, ONNX Runtime works there too. So all you do is change the execution provider from DML EP to whatever I want over here, whether it's QNN EP on Android or Linux or what have you, what you want to do, CoreML EP on Apple or iOS. So it just allows that ease of use and is importantly where I make my investment if I start on Windows apps and add AI here, or I start on iOS or Android and want to port it over to Windows, it again makes it super easy to do. Now, and also because we've added Olive, allows me the flexibility either to go to, again, DML EP and just do it once for Windows, or I can do it for every hardware I want. It's a extensible hardware framework or tool chain with Olive. Again, it's open source, so people can contribute to it. All of the silicon providers are putting in their optimization techniques. You'll see from Vicente in a second of what we've done with Whisper models to help create single graphs and do some interesting work there for a different form of optimization as well as just pure performance. And then adding ONNX Runtime with the Azure EP gives us that hybrid flexibility and again, control back in the developer's hand. So with that, let me hand it over.
You can keep going. Okay. Yeah, I got the other one. All right. Hi. Hi, everyone. So today we're going to be covering a Whisper audio transcription model inside a C# app. But before we do that, let's quickly look at... Yeah, change. Okay. let's quickly look at the model that we're going to be using. So we're going to be using the Whisper model, which come in various sizes. It goes from tiny to large, with variance of around 20% for the tiny on word error reporting, and we also have around 9% for the large. We're going to be picking the tiny version to run local inferencing and the large version running on the cloud, and then you can pick, depending on your conditions, where you want to run this model. If you want, why is this not working? Okay. If you want to see, how do we run on your PC? So today, if you were to do this with a stock ONNX model, Whisper model, you convert it, and then you will end up having two models, one encoder, one decoder. Then you have to inferencing those separate. You will have to also take your audio file, process that audio file by hand on your application, and then once you do that, you will need to get the decoder output and convert it into a string, and then show it on your app. So we're going to show you now how using Olive you can shortcut this process and make it so much easier for you to integrate. All right, so now let's go do a demo. Share my screen. You need to share the whole screen. Here we go. Close this. All right, so first of all, and I forgot to close that. All right, here we go. So the first thing that you will want to do is you will head out to the, why is not my screen there? Stop sharing. Do it again. There it is. All right. So the first thing that you will want to do is you will want to head out to the GitHub repository for Olive. And then in there, you're going to have all the instructions how to get that installed and pip install. I have that on my machine now. But the most important piece that we have done is you can come in here into the examples, and you can see we have a list of models that we have worked in the team to prepare for you. And you can take this and do your own optimizations. Today, we're going to be looking at the Whisper one. In the Whisper one, we created some convenience scripts for you where you can run the scripts and generate some config files that we're going to look into. We prepare some of the different options for you to generate as part of this. So the first thing that we will need to do is, you will go to Hugging Face, research your model, figure out what is the model that you want to use. In this case, we're picking up the Whisper Tiny English version is the one that we're going to be using. After you pick your model and you have identified, what do you want to do with that model in your app, you will head out to our instructions for Olive, and this is the documentation. So the first thing that Olive is going to need, like Jeff said, is a configuration file. In this configuration file, you're going to be providing a bunch of different sections, which I'm going to cover once we do the conversion. But you can come in here, read about each of the sections. I'm not going to go into details of all the parameters that you can put in and tweak. But know this, like if you want to extend it, you have the code. You can create your own plugins and put into the tool. So if you have any other evaluators and things like that, you will be able to do this. All right. So now let's go do some code. All right, so the first thing that we want to do, you guys don't see that? Perfect, okay, because this thing is floating around. All right, the first thing that we're gonna do is basically go in and generate the configuration files that I said. So on this examples, we already create either the config for you or we give you a tool to generate the config. So in this case, we're gonna go in and run the Whisper Tiny one. This is gonna go to Hugging Face, download the Tiny model. In this case, I already downloaded it, so you don't see the Hugging Face bars in there. And then it will go in and generate all the configs for you. So this configs right here, not that. I swear I left this where it should have been. And here we go. Okay, so Whisper. Here. So this has generated these files right here. So it generated all the configs for you for all the different variations that you actually want to do. In our case, we actually want to look at the CPU int8 is the one that I'm going to be showing to you today. So we can come in here and open this. We trust it. All right, so this is the config file that you all see, and when you will get that. And in here, you can see the first section that we have is input model. So this is the model that you want to be using for converting. You will set up the model, it will put the name, we'll put the model in there with some components about the information that you need for this to run this model. Then after that, you have what is the target system that you're going to be using. In this case, we want to target CPU, so you will put the information in there. Then after that, you're going to be describing what are your evaluators. In this case, we're going to be using latency as our metric for checking out what is the most efficient model for me to use. and this is going to be run about after each pass to determine what is the best option for me after this. Then now we have the different passes that the tool is going to be running. In here, the first one that we do is the ONNX conversion and the target offset that we want to convert from the regular model. Then we have quantization for the ONNX model. And after we do that, we're going to have a new instruction set that we actually added to the ORT extensions. And this is what actually starts helping you in your application, because this beam search operation is basically taking the encoder model and the decoder model and joining them together. So instead of you having to deal with two models in your application, we're going to do all that logic within one single graph. So it's all connected together. We also added pre and post processing for operations in the system. Again, these are all extensions on the ORT extension package. We are doing all your audio processing in here, like conversion from stereo to mono. We're doing the audio resampling, and we're also doing the log-mail spectral, the spectral conversion. And then in there, after you do that, we also do the post-processing to take the decoder output, and we convert that into the string, and that will give you your translation. So after you have this file, in this case, we generate it for you, so you don't have to do much. You can go back to that directory, and now we're going to go ahead and run the setup for this. So the first thing that you do, you basically call Olive. So you have here Olive workflow run, and you're going to pass in the config. In this case, we want the CPU int 8, and we're going to run setup first. So what this is going to do is it's going to look at your config, and it's going to make sure that you have all the dependencies that are needed for you to run this optimization. After that is done, in this case, it decided to install ONNX Runtimes because I didn't have it. We're going to run the exact same script to do the actual conversion, and this is going to take the original model and do the junction and output an ONNX model that is end-to-end for Whisper. And in here, we should see the output. So here are all the output for each of the passes that it decided to do, and then it actually created a zip file with all the artifacts that I'm going to need to put this into a C# application, or Python application for that matter. And then if we go back here, it generated this model directory, and this is the file. I already extracted it, so it's easier for us to see. So in here, you're going to basically get your candidate model. So this is the model that the tool decided that is the best model for you to use in your application based on the evaluators that you actually set. Then you're also going to have what are some of the packages that you're going to need to include in your applications. In the C# case, which is the one that we're going to be using, it has a NuGet package that you can reference in there. Then you also have some sample code for each of these platforms to how to integrate it in your application. So once you have that, at this point, now you're ready to go in and start integrating this into your application. But before we do that, I want to go ahead and show you what I meant by the changes that it did to the model for you. So if you had gotten a regular model, we will be inspecting two different models, one encoder, one decoder, like we said before. In this case, we basically expect one audio stream in the model. Then you see all the audio processing operations that we already gave you as part of the ORT extensions. Then we have our model information, and then we have everything going into that beam search that I mentioned earlier, and then connecting it to a decoder. And then your output now is just a string. So now you end up with one single end-to-end graph that it's able to take your audio back to string, and it will be much easier for you to then integrate this into applications, and not just C#, but this could be Python, and the logic and the amount of code that you will have to do, it's pretty minimal because it's all integrated in the model. Now let's go quickly take a look at that. All right, so in this app right here, I already went and took the model.onnx file that I just showed you. I copied it here, and I put it in my applications. And the first thing I want to go ahead and show is we created this object here. This is what we call our object config for Whisper. And in here, you basically select which is your execution provider that you want to actually use. In this case, we're going to be focusing on Azure and CPU, but you can also run it on CUDA, DML, and anything else that you actually implement that is supported by the ONNX Runtime. These are all the parameters that are needed to configure the session that we're going to be using for inferencing. And then in here, which is the other very important method, it's how do we configure our EP, our execution providers for each of the selections that we have available. In this case, if you look at the Azure one, you need to configure a couple things in here. You need to tell it which is the endpoint that you're going to hit. We're going to be hitting OpenAI today. And then you have also the URL endpoint that you're going to be doing, and the name of the model, because that's what OpenAI requires you to send. And execution CPU is just a standard CPU execution provider. Then the next file that you have to worry about is how do you actually inference this in there. So a couple things that you have to do is you need to run the inference. That is the most important part, and create all the input models in the right format, in the right tensor format, so you can pass it into the model. So the first thing that we're going to do is we get the Whisper config, and we're going to get the audio file that was selected in the UI, and I'm going to show you that in a minute. Then we'll load that from the system and get the byte array from that. From there, we convert this into a tensor, and then we pass it into this method to actually create all the information, the extra information that we need to pass into the model. Once we do that, we're going to be checking for connectivity. This is the piece that, for sake of the example, we have a toggle in the UI, and we're turning on and off the cloud inferencing, but this could be coming from either checking connectivity on your machine. This could also be coming from any other heuristics that you decide to put on your application. And you can, in order to use for changing from CPU to cloud, it's just a matter of setting a different execution provider, and obviously providing some configurations around authentication and enabling the Azure piece in here like I did. All right. So this is sort of like high level, all the code that you need to start the inferencing, and then let's just run it. All right. So first, we're going to run with cloud inferencing on. This is what I meant. So here, I'm just manually doing this so I can show it to you. So the first thing we're going to do is come in here, grab an audio file, and then we're going to call transcribe. So in here now, we're basically saying, we said, yeah, let's run use cloud inferencing. You can see is cloud inference is true. So we're going to set that, and then we jump into the EP configuration. So when we look at this, now it already run and it set up all the Azure provider. We do F5. And we should get a translation back. There's internet. There you go. So we have our translation, and it's calling in there. Now, same app, no code changes. All we had to do at runtime was say, like, OK, there's no internet now, and I still want to go ahead and do this. I'm going to load the same audio file because I didn't think about it, and I should have had to. But it will be wiped out, so you can see. So in this case, we say, like, yeah, there's no cloud inferencing, so it's going to skip the setup for Azure. And then it's going to be using now our CPU provider, which is going to be calling into our local model that is doing the inferencing. So we do that. It does, again, the same inferencing. No code changes in the application whatsoever. It's using the same flow that you will have for ONNX. It's super simple. Now, because we have that, and like I said, you have one single model that can do end-to-end this conversion. We can also do this on the web. So if we come here, we already have this app, and I just want to briefly show you. So this is using the Wasm execution provider. So we have a tool. I'm going to go ahead and load the same audio file again here. And then we're going to say transcribe. And maybe it will transcribe. Okay, let me refresh the page. Okay, let's do it again, one more time. And why is it not letting me transcribe? Oh, it's loading the model, sorry. I refreshed it. All right, so now we can hit transcribe, and it should actually output the transcription. Here it is. All right, so let me show you now what that code looks like. So in here, we have a very similar setup. So we have a class that has the Whisper configuration. If you remember, our creation for the inputs in the model is basically this top part here. This is how we have the execution provider. And then we're creating an inferencing session and then running it down here. Apart from that, it's the same model. No extra processing for the audio file, no extra processing for the decoder output, and everything was just connected. So this is how we expect you to actually take these models and use these tools to be able to connect from local inferencing to the cloud, and using the hybrid loop application patterns to actually bring the flexibility to your apps and run this, whatever you actually needed as you're building your applications. And that's it.
All right, since there's no questions, we'll just wrap. So I'll pass the mic out for anyone that has questions. I do see there's one on there. We have the development leads from Olive, from the QNN EP, from the Azure EP, as well as DML EP in the room. So we'll be able to ask questions kind of around the board, as well as, we have Vicente and I as well here, who we probably didn't do any introductions for. So, yeah, I'm on the ONNX Runtime team, responsible for Hybrid and Edge. I'm the PM responsible for that, and Vicente.
I work in the Windows Silicon integration team.
Yeah. So that would have been good probably about 20 minutes ago, but that's all right. So any questions in the room, and then I'll hit the one I see in chat already. Right here. Oh, sorry. Whose was up first? Is that? I'll go right to left. I'll go right to left, and I'll try to remember to speak in the mic.
Thank you. You mentioned Intel and AMD and Qualcomm at the beginning. What about NVIDIA?
So NVIDIA GPUs, CPUs, et cetera, absolutely. NVIDIA NPUs are coming.
Does it work in traditional GPUs as well?
Yes.
Yeah. Oh, yeah, absolutely. So CPU, GPU coverage.
So my 3090s,
Everything.
Okay.
Doesn't matter. Yeah, any GPUs. That's why I said so both you can go direct to like CUDA EPs or
DML.
Or use DML to cover all GPUs in the Windows ecosystem. And that way you do all at once for DML EP, and it just works in the Windows environment across CPU and GPU completely. And coming is NPU coverage using DML for Windows. And then, or you can go directly to the execution providers for the specific GPU silicon as well. Okay.
Could you unwrap the ONNX config if, let's say, I had a confidential model that I didn't want anyone to be able to see, but I wanted to disseminate it maybe on a web page or something? Is it possible to unwrap it, or once it's wrapped up, it can't be unwrapped?
I do not know if it can be unwrapped.
Hey, Pranav, can you unmute? Actually, can all the folks online unmute?
Yeah.
Okay. Do you want to answer that one?
Sorry, can you repeat the question?
Sure. Once with the ONNX model, can you once it's if I have a custom model that I put into the ONNX runtime, can it be extracted from there? If I had like a confidential model where I wanted to protect it, but I still wanted it, let's say, on a public web page in WASM.
Oh, this is a question for ORT Web. There is no security. I mean, ONNX Runtime is not really in the business of securing the models. So, yeah, I don't think this.
You can still get it. Yes, is the answer. Now I answer your question. Yes, the model is not locked. Like if once it's converted into model, others can look into it and look at it. Yes.
Okay, let me take one. Do you support JavaScript, TypeScript as well? I'm assuming you mean on the Olive and/or ONNX Runtime. So right now, the sample boilerplate code from ONNX Runtime only produces the sample code for C++, C#, and Python, but ONNX Runtime will run just about anywhere. Is there any other comments from the experts online that want to?
Yeah, so I replied to that question. So actually for like JavaScript, there are two ways using ONNX Runtime. So you can use ONNX Runtime Web in the browser, or you can use the Node.js binding if you want to like use JavaScript in your Node.js environment.
Okay. So if you need any follow-up, go ahead and ask online. Any other in-room questions? Sorry, I started on that half and then skipped over here. Or did we answer? Wow. All right. I think so just for the folks in the room, timeline for web GPU. The preview is already released in ONNX 1.15, which was released on Tuesday, the 23rd of this week in concert with Build. And I think Emma, answered all of those too. ROT web demo. Okay. Can you use any model found on Hugging Face or just certain types? I assume you mean for Olive conversion. Is that otherwise you can use any model that in PyTorch, convert it to ONNX. It'll work on ONNX Runtime. So for that, you can. So Emma or Devang, you want to answer that?
So Olive supports the most popular transformer models in Hugging Face. So feel free to have a try. We have already created some end-to-end examples for BERT. And like you can take that example as base, like update the configuration file for like a GPT or T5 model. So I would say we have already validated most of the Hugging Face models.
Okay. Any other in-room questions? Yes. Hold on.
Yeah. All right. So first of all, I do apologize if this is a noob question. So I'm familiar, and I've worked with the Microsoft ML tools and .NET C# creating ML models using that tool set, and I'm kind of curious where the ONNX runtime plays with those types of models that get created, and if they have any opportunity to take advantage of the new ONNX runtime being baked into the operating system that you guys are talking about.
Do you know that?
I do not know.
So what specific tool chain, or I guess would probably be a good qualification when you say you're using .NET?
So it has been a minute since I used it, but a long time ago it wasn't .NET. It's the .NET machine learning tool. Yeah, ML.NET. Thank you. Yeah, the ML.NET tool set.
Is that,
Sorry.
It's awesome.
oh, okay. Keisha, are you?
It is something that we're aware of, and we are working to integrate the ONNX runtime with DML into that.
Okay. So the answer was the DirectML EP team is working on integrating the .NET ML. They're aware of it and looking for the plan that they're going to incorporate. Okay.
Well, my question was what the plans are to be supported.
Right.
Is it going to be supported, or is this
At some time in the future, yes.
So the answer is that sometime in the future they will support it. They are aware of it. Yes.
So I noticed some. Thanks. I noticed some kind of a selection kind of process part of the conversion of the model. So for I don't know something like scikit-learn or some other models, will there be similar conversion, or is there some way to just kind of map them up and store them in, I don't know, in some kind of model repository for everyone, kind of for whatever reuse?
So do you mean for Olive specifically, or for just in general?
In more general, is it always within ONNX that you need to use some additional data, and there's some kind of selection process of which of the conversions to select, or is it there's like a more one-to-one mapping for some of the use cases?
So Jeff?
Yeah, go ahead.
Yeah, I think he's asking for like how to run scikit-learn model with ONNX or ONNX runtime, right? Is my understanding right?
It's a bit more general. Sorry, it's a bit more general. It's I'll kind of break it down. So one is part of ONNX conversion. There's multiple models that get created that get evaluated. Is that right?
as part of the Olive optimization?
Okay, good. So second, does this process happen for all the different frameworks, whether it's scikit-learn or is it just for transformers and things like that?
So currently Olive supports PyTorch model and ONNX model. So scikit-learn, you can use the standalone scikit-learn to ONNX conversion for like converting the scikit-learn model to use ONNX runtime. For Olive, we haven't enabled scikit-learn model yet, but that's something we can take a look. Devang, do you have anything to add on?
No, apart from PyTorch and ONNX model, Olive can also handle the Hugging Face optimal models directly. And Olive is an extensible package, so it will be very simple to introduce your own conversion for scikit models also. But as Emma said, if there is a need, we can extend Olive to introduce a scikit model conversion step.
Yeah, but having said that, I should add that there is a scikit-learn converter to ONNX already in open source, and you should be able to use that.
Yeah, so immediately you can just use, because there's ONNX is a transportable framework, so that way you convert to it and to convert to any other framework too, is one way to. Oh, okay, yeah, that's a good, okay, so the question is where does Olive end and begin, and where does ONNX runtime begin and end? And I think that's a good thing to point out. So think of Olive will take a model and a configuration file and optimize that model based on that configuration for specific hardware. It's a hardware-aware optimization tool chain and framework. And it is extensible, it's open source, so anyone can contribute to it, and it will continue to expand in coverage for different aspects. So, but that is where Olive begins and ends, but it creates the package you saw with ONNX Runtime, the right execution provider, the optimized models for that specific hardware, and then the boilerplate code as well as the configuration file for ONNX Runtime to be most optimal based on what you wanted it to optimize for. And then ONNX Runtime is I can run it on to inference in, an ONNX model on any platform, effectively across any silicon. There is no, yeah. I could skip Olive and just run an ONNX model, and it'll do just-in-time optimization for that. And if I'm using it on that execution provider specifically for that silicon in that platform. Okay.
Yeah, and to add on to what Jeff has mentioned, so actually Olive works well with ONNX Runtime as an end-to-end inference optimization solution. If you are aware of ONNX Runtime, so ONNX Runtime acts as a unified inference engine, like for hardware accelerator integration, while Olive acts as a unified model optimization framework for hardware-specific optimization toolchain integration. So the end-to-end flow is that given a model and a hardware target, Olive can generate the optimized model that can run really efficient with ONNX Runtime with different EPs.
If I got it right at the beginning of the session, you mentioned that one of the reasons for doing local inferencing maybe, or cloud inferencing, maybe that a certain model, you require better accuracy and the model on the device may not be as good as. So does it mean that when you use Olive and you optimize for a specific device, then you need to have multiple optimizations in place? Or with ONNX, do you have the same quantization, the same setup that would run regardless of the hardware?
So the answer is yes, you can do either. So you can optimize specifically to get the best performance on each hardware. So I could run it on my Qualcomm device with their NPUs and target the NPU for that device. I could do it on NVIDIA GPU machines specifically with an execution provider for that. Or I could use DML-EP and do it across all GPUs in the Windows ecosystem, and I optimize once for all of that. But I can also choose if I want to go, and I could have as many configurations as I want to be optimized for each particular piece of silicon using an execution provider. So think of execution providers as a hardware accelerator. And I can either abstract that away and do it once across Windows ecosystem with DML-EP, DirectML-EP, or I can do it for each specific piece of each GPU or each NPU. Did I answer that fully? Or if not?
But then if the hardware is not there for that case, right? So if we optimize for Qualcomm or for the Meteor Lake or each of these NPUs, right? And if a certain platform doesn't have that, you would know to default to the CPU or that's the...
Right, so you wouldn't, yeah, so if it doesn't exist, you would, and you're running, because you run it on the hardware. So you optimize on that hardware itself so it would know it doesn't exist. It wouldn't have an execution provider for it if you're running on that. If you're just trying to do a general model and you run ONNX, it will, you can run it on just CPU or fall back to CPU. And that's usually a parameter you'd set as to do I want it to or not. Did that? Okay.
So the Whisper demo that you showed that was running both in the cloud and offline, was it assuming the same model running on both platforms with the same optimizations? Or?
No, it's running the Whisper Large on the cloud, on optimized, and it was running the optimized version of Tiny locally.
Thank you.
One caveat, and let me come over here as we ask more questions, is it does require the same input and output locally and in the cloud because it is a single, you make it to the same API. So it's expecting the same input and output.
So I'm sorry if this has already been covered in any way, but so this is only for like desktop. Once if you want to run AIs, but you want to optimize them for things like phones or tablets, how would you, if that's possible, set it up?
For phones and tablets, or you mean, well, how do you do it for the cloud?
So how would you set it up? So because you might want to have a image recognizer built for an app on your phone, right, rather than on a desktop PC.
Yeah. So how do I optimize it? Because ONNX Runtime will work on your Android, iOS, et cetera devices. With Olive. Emma and Devang, you want to answer? How would I use this or extend Olive to run on my phone and or tablet?
So take the Whisper demo as an example. So as you can see, we optimize the Whisper Tiny model, and that optimized model can be used in the desktop as well as in the browser. So I would say, once we get one single optimized ONNX version, you can use it across platform.
Is there a plan for Olive to be able to run on an Android phone, for example?
Yeah, so that model can be also run in Android. I think we have already built up a demo with ONNX Runtime Mobile using the same Whisper model that is not showing here. But I would say this is specific to the Whisper demo. If there are some other demos, we need to take a look at. Since the optimization varies from models and given hardware.
Oh, okay. Yes.
Just to reiterate, so that I have it clear in my mind. So for us to have a model optimized for all types of hardware, we need to use DirectML EP. Is that what we are saying?
I'm saying you can go different paths. If I want to optimize once and go today across all Windows ecosystem, CPU and GPU today, I use DML EP, and I use Olive. I optimize once. DML EP use the same model across all Windows ecosystem hardware. For now, if I want to go NPU, I've got to use. I would have to use QAnon EP, OpenVINO EP, or Vitis EP. Eventually, or in the coming future, for Windows ecosystem, DML EP will cover NPUs. It just doesn't as of today. But yeah, you can always go optimize specifically for the different silicon types too. So it just depends on what are you trying to accomplish, and if I want to do it once and it just works, I can just use DML EP. If I want to go specific to each hardware type, I can do that too. Or I can do a mix. I can do a mix as well. Just depends. Are there any questions on the chat? Sorry, I've been walking around here so much. I'm neglecting our online audience.
Nope.
We have 2 minutes left, so let me.
So in the optimization step, I saw that you optimized for latency, which I assume is the lowest latency. But is there a way to be more granular and kind of have like a slider of sorts, like this is the latency that is required or acceptable, and so don't quantize more than this amount to achieve that?
So I know the default ones, like Emma and Devang can share, but the evaluators are extensible, so you can create your own. If you want to specify some custom evaluator, you could do that too. I don't know if the default one supports that today. Devang or Emma, do you know?
Yes, you can provide a threshold of how much, or you can provide a range also. And in addition to latency, you can also have evaluate for accuracy, F1 score, accuracy score, etc. And Olive will support all the torch metrics, basic matrices, as well as the Hugging Face matrices.
Okay. All right, we're at time, so I want to thank everyone in the room and online. Very good conversation, appreciate it. And again, hit Olive, hit ONNX Runtime, onnxruntime.ai. You can find all of this as well as links to Olive, onnxruntime.ai/build 2023. You can see the blogs as well as the repos for the Whisper, as well as several other of the demos. Again, you can do it all today. It exists. Thank you.